Okay, just trial, sir. I will speak from there. I will speak from here. Okay. There is
Both of you are audible, no problem. Nagraj, both terminals are audible.
Sir, can you hear me? Are you hearing?
No, sir. Using computer for audio. Then, no, you come here, sir. Come here. Audio, speaker. That one you click. You test. You can check whether it is muted.
Hello? Hello? You speak, sir?
Hello.
No.
Hello.
You are just there again. Stop.
There. It is okay only.
Speak, sir. Hello?
Okay, you are audible. You are audible, Sriram.
Wait, I will come. Wait.
Nagraj?
No. Can you check now? Yes, sir. Yes, you click here.
Use computer audio or system audio.
Now it is audio. You speak, sir. Okay.
Okay, you are audible, Sriram. You are audible. That's okay.
Okay.
Shall we wait for 5 minutes, sir?
Yeah, sure, sir.
You can mute down if you want to mute.
I think 12 are there already from customer side. Can we start, Sriram? Are you ready?
Yes, madam, we can start.
Okay. Good afternoon, everyone. Welcome to the second session of this Valmet DNA today. And this FB CAD will now also continue because it is a vast subject. And morning you had a very good session from Kiran Kumar. Now Mr. Sriram will take up the session. I will read a short biodata of Sriram. He's been with us for quite some time, and now he's handled major Valmet DNA projects like Arcelor Mittal 1 into 27 megawatt, Nalco Damanjodi, RUPPL Jamnagar, ONGC Hazira, NMDC turbo blowers, and North Chennai 800 megawatt project also he has handled, and 9 copyrights have been filed by him in the area of steam turbine controls. So he is quite knowledgeable about this, and we can make use of his experiences and kindly come up with more and more number of questions because this is a interactive session and he will directly connect himself to the Valmediania server and go ahead. So let me now welcome Sriram also to take up the session. Sriram, I am passing the host rights to you now and you can get along with it.
Yeah, thank you, madam. Good afternoon, everyone. Uh, yeah, is my share screen visible to all, sir?
Oh, yes, it is visible, Sriram. Go ahead.
Yeah. Good afternoon, everyone. So now we will have the second session for this DNA Explorer and FBCAT. So I think morning you have got the basic of all this DNA Explorer, how to open a loop and what all features are there, how to view the that is different hierarchies, what is there, and how to download and how to get it. That you might have seen. So now we will see the insights of FBCAT, like how to make a logic, what all things we have to see while making a logic, what all attributes are there, what all design parameters we have to see. So in those aspects we will see as of now. So okay, so let us come from a basic thing. Like suppose you want to create a new function block diagram, that is FPCAD. So you have to go in this DNA Explorer object. One create one button is there. So here you can go for this function block diagram. So now this basic function block diagram has opened. So this is like how you have to start your FPCAD from scratch actually. So once you are starting from scratch like this, you have to create a loop basically, function block diagram loop. So here if you see in top there is a name is there, and then package is there, and then execution time is there. So these all you have to configure as per your requirement. And if you come to this bottom, here also one tag code, one attribute is there. So this also will be changing as per your whatever loop you are going to design. So now we will see like how to configure these things. So to edit these things, you have to go to this edit and then click on this values. And then you have to click on the parameter which you want to edit. Suppose like I want to change this name, package. So I will click here. So here it will ask me like pr tag code.f and then this package. Suppose like I want to create some signal for like say like speed control. So like I will write it as 1 speed underscore ctrl. So now this package identifier whatever you are entering here, that is the package in which this loop will get downloaded to. So you have to enter the correct package name what is assigned in your ACN for this specific loop what you are creating. So let me put AP21. So this execution time is based upon your requirement basically. So it is in millisecond. So you can give whatever millisecond is there. Suppose like very critical tags we even give 20 millisecond. Like suppose in each channel. But generally we give around like 500 milliseconds or 1000 milliseconds we give. And this is like a total loop execution time or not a single block execution time. And this execution order is like in what priority you want your loop to execute. The least number will get executed first. Suppose like 20 will get executed first and then 21 will get executed. And then for this tag code, once again you have to go to this edit values and then click on this tag code. So here when you are entering this loop tag, you have to remember that whatever you are entered in the top in name, same thing you have to enter here. I have entered one. You see it is pr colon 1 speed underscore control dot f. So here also it should be like same 1 speed underscore ctrl. So this you should not enter a different value here. And this loop name field one, it is like a description. So here you can enter like speed control. And if you want this name of planner here, this also you can identify. This process area will automatically come based upon like which process group you are going to put your loop into. So now I am giving this okay. So after initialization of your loop, every time you have to go to this file and then you can give this check. This check function will check for any compilation errors that is available, that is made in your loop. So if any compilation errors are there, it will report it. So now as of now, no compilation error is there. So it is asking me directly to save the engineering object. I am clicking yes. It is asking for this database. You have to choose whichever database you want, repository or default workspace or library. So I am choosing repository. So now it is saved in my repository. Is there any doubts for anyone in this? Hello? Is there any doubts for anyone, sir, in what I have said as of now? Okay. Okay, sir. Then we will continue. So, yeah. So now I have saved this function. But once you are initializing it, we have not mentioned any area in which it will get saved. So it will usually go to this not categorized. Here it will appear. So now this loop has come here because we have not given any process area for this loop while making the loop. So you can drag and drop to any of your location which is required. Suppose like I want to put it in this Nalco 8. So I will left click on the speed control, select it, hold the left click and you have to drag it here and you have to put it in this PI header pressure. Suppose that is where you want to put this loop. So now it has already gone to this PI header pressure. So if you here, if you see, it has come here. Suppose now if I once again open it here, huh. Now if you see in these values, if I click on this tag, you can see already this process area, all these things are entered directly. This is based upon which folder you have put your loop in. So this will automatically come. Process area 1, 2, 3, 4 will automatically come. So once you analyze, once you initialize it to a specific group, this will automatically enter. So you have to fill only this loop tag, and then in the top you have to give this name. Name will usually start with this PR colon and it will end with .f. So that is like a standard what we are following. So and then this package will be based upon your ACN name. So these two things you have to keep in mind and you have to enter for each and every loop. Now what we will do is we will make some add some basic blocks and we will see like how to connect those blocks in this FBCAT. So initially there are some things called like ports, what we say. That is like suppose if you want to enter any constants in your logic or you want to enter a tag from some other point in logic to this logic. So different kinds of ports are there which you have to configure in this FBCAT. So we will see these ports one by one. So first what we will see is interface in. You can go to this common and then you can go for this interface in. Interface in is used for giving inputs to this loop. So once I click this interface in, there are like multiple interface in blocks which is appearing based upon the data type. Suppose like you are having analog, you have to select analog. If you are using binary, you have to select this bin. With binary event means you have to select this bin event. Analog with event means you have to select this analog event. And integer is there. And any function is also there. That is like you are not knowing what is the data type. Then you can use this any also. So mostly we will be using only this ANA or bin data types. Okay, I think someone has asked like in tag one speed underscore control you have entered. Actually this prefix 1 we use for this unit number because like different units will have different prefixes. Suppose like you are having 3 units together, then I will be using one speed underscore control for unit 1, 2 speed underscore control for unit 2, and 3 speed underscore control for unit 3. So that is the importance of that prefix 1 actually. So I will tell you like how we convert the software for different units also. So now we can continue with this interface port. So I will add one bin. I will click OK. So when making this loops, you can always enter it in the left side. So this is like for you can keep this interface port anywhere, but for the what to say aesthetic look of the loop, you can keep it on this line actually, so that it will look like all inputs are in the left side and all outputs are in the right side. So this input one, if you want, you can enter any command text. Suppose like binary, I can enter, and initial value whether you want 0 or you want 1. So this will be the initial value that the logic will be taking once it is getting downloaded or whenever your AC is rebooting. Okay, one more that is okay. Package name and process area name need not be same. That is actually not a requirement of Metso because okay, I have just for sample I have put it here. But it is recommended that you arrange it in a fashion like you arrange it in a correct group. That is AP21. You can put it in AP21 because I have not exactly counted here. So I have put it in BP. But in your logics or in your site, wherever you are using, AP21 logics will be put under AP21 folder only. So that you will be able to easily identify that which this package is for AP21. Okay, ANA and ANA event, what is the difference? Basically, whenever the time changes, event data type is for like it will give the value as well as the time change. That is, at one point that value has changed, so that time stamping will be there in addition to the value. So that is the main difference between this ANA and ANA event data types. But usually we don't use any ANA event data type. We use mainly binary event only because we don't use any time stamping for analog values. So in our logics, usually you may see ANA or binary event. These three are the main data types which is used. Okay, now I have created this interface port. So if you want to edit anything in the interface port what you have created, you can once again go to this edit, values, and then click on this port. So once again whatever we have entered it will automatically come. So this initial value whatever I am telling, this interface port behaves like a constant. That is like you can give any constant here. Suppose like 0 I am giving and I am clicking OK. So this port will always pass 0 to your logic. If I want to make it to pass 1, then I have to give 1 year. So this interface port is used for constants basically. So whenever you want to introduce a constant in your logic, you can use this interface port. And there is one more option here. I will once again go to this edit values. So suppose I want to change this value online from 0, 1 or whatever I want for troubleshooting. So after this, whatever initial value I have given, I will put 1. Hello. Sir, your voice is not audible, sir. So after this, whatever sir, your voice is not clear. It is breaking. Hello. Sir. Sir, we will continue. If any queries are there, you can enter in chat. I think voice is breaking actually. So this initial value, if suppose you want to change it online, then you have to enter this special character which is called @. So I will give like 1 and then @. So suppose when you put this @, definitely when you are downloading this logic, it will try to pass the value of 1 only. But you will be able to change the value 1 to 0 or 1 in online. That is when you are online itself, you will be able to change this value. Without this @, you cannot change the value from 1 to 0 or 0 to 1 like that. So you have to once again change it in the FVCAD and then you have to give a download. So if you are putting this at the rate, you can directly change the value of this interface port online without having to give any download. That is one advantage what this at the rate function gives. So this is for this. Hello. Sir, voice is not audible, sir. You can also enter in chat actually. You can send your query in chat. Okay, sir. Next, we will see this locals. So this locals I will see. I will show you. It is of same type only, like your interface port. But what the difference here is, you can give a dimension of data. That is like in interface port, you can enter only one data, whereas in locals, you can enter multiple data at once. So it is like what we use for this function generators. Suppose like in function generator, you have to give say like some 5 x values and then 5 y values. So you have to use this local port for that. So that dimension of data, I will make it as 5 because 5 x values I am going to give. And this comment text I will, this name I will keep it as like x. And then comment text I will keep like x value. And then initial value, whatever the 5 x values are there, that you can give. Suppose like 2 comma 4 comma 6 comma 8 comma 10. So these 5 values it will take in a single port. So you do not have to give 5 different ports for that. So these 5 values you can give in a one single shot in one single port. So for this applications you have to use this local ports. Here also this and symbol at the rate symbol can be used, so that if you want to change in online these values, you can be able to change it. So this is the function of local port. Now we will see this external in continuous port. So in any port, whatever we take the data types, based upon data types, you have to choose your corresponding ports actually. So here I will suppose I will take this bin and then I will keep it here. So here same type. This external port is basically for connecting some logic which is there in a some other loop to this loop. So suppose there is a logic for speed actual in some other loop which I want to connect it in this speed controller loop. I will write 1 underscore speed underscore actual. So this tag whatever you are entering here in this external continuous input name should match your whatever your source tag is there. So suppose in your source tag it is like speed actual dot f colon me, then you have to give dot f colon me. But suppose your destination tag is only like pr colon speed actual, then you have to give only pr colon speed actual. Okay, so now once I added this external input tag is added. So this you can directly connect in logic and use it. And there is also one direct access is there. This direct access ports, usually this left port is for like that is for outputs basically. So what is the difference between this external in continuous and this direct access port? Because this direct access port, once you define it, this becomes like a tag name for whatever output you want to give. So you can use it anywhere in your other logics. basically, just a minute. What about the initial value of external port? Actually, one query has come. Okay, I will show you this one, sir. Edit values. If you click on this external port, here also an initial value function is there. So any port, whatever you are creating, it will show a initial value by default. So it will always take this 0 in case of this external input port. So if you want to change it as 1, you can give it as 1. Otherwise, it will always take 0. And once after initialization, anyway your source input, that is the speed actual, will start coming here. So it will take the speed actual itself. I think this, okay, I should have made it as analog actually. Okay, now I have added this analog ports for the speed actual. So this initial value, it will be taking like this one, whatever we are entering here. And then this, it will start to take this speed actual. Basically, the purpose of initial value is like whenever you are downloading or like your ACN is booting, it will not directly take from your source. It will need some like initial value so that it will start from there. So that is like an initial value. So what is the value it will start with, and then it will start connecting with the speed actual. So by default, it will start with whatever initial value you are giving here. Suppose if I am giving 0, it will start with 0 while booting or while while you are downloading. In both cases, try to start with the initial value first, and then, but that may be for a millisecond interval or whatever you are giving in this execution time. So after that, it will start connecting with your speed actual. So while choosing an initial value, you should be like clear that your initial value should not hamper your process when you are giving a download. So that is like a fail-safe value. That is what you should select as an initial value. Coming to this direct access port. So now this direct access port, when you create this, whatever direct access port name you are giving, you can directly use this anywhere in your some other logics or in your pictures. Directly this name you can use it. So that is one advantage. So suppose here I am. So suppose this tag I am creating one speed underscore GT90, that is speed greater than 90 RPM. So now this wherever whichever logic I want to use the speed greater than 90 RPM, I can directly call this tag PR colon 1 speed underscore GT90 so that I can connect that logic directly. So this is for this direct access port. So suppose we will now see like how to use these different ports in some other logic. So suppose I am also creating one interface output. And I will assign this also as speed greater than 90 RPM. Okay. Now the speed actual I have created here. So now the speed actual is here, and these two blocks are there. That is, one is for direct access bot block and one is interface out block. So now this direct access block if I use in the destination logic, I can directly, in my external input, I can directly enter it as PR:1 speed underscore GT90. Directly I can enter this, whatever name is there in this direct access block. But suppose if I want to use it via this interface out, then I have to enter the name of the loop in which this interface out is there. That is, this interface out block is now configured in PR:1 speed underscore CTRL dot F. And then I have to enter the name of this interface out block, that is :out1. So if you want this thing, I will write here and show you. If I want to use the direct access block, I can directly write like this and take the signal. This you can use in anywhere, not just in your package. In any package, this tag you can use. It is irrespective of like your packages. Basically, this tag is available for use for any package. Suppose if I want to use it via this interface output. Then I have to enter the loop name, that is PR:1 speed underscore CTRL dot F, and then the name of this interface output block, which is out1. One thing you have to remember here is in this Walmart is case specific. So if you are giving capital letters, you have to use capital letters everywhere. And if you are using small letters, you have to use small letters. Otherwise, it will throw an error. So this is how you have to cross-reference interface block. So if you use a direct access block, it is easy to remember because directly whatever name you have entered in the direct access block, you can use it in the external input. So if you are using this interface out, you have to see that you are entering the correct loop name and then you are entering the correct interface output name. So that is the advantage of using this direct access blocks. Okay, and last one, what is left is this. Suppose you do not want to create a port and you directly want to use some constants in your logic. So these constants you can use actually. This will get directly attached to your whatever block you want to connect. There you can directly connect this and you can give this value here. Okay, so can I find the direct access tag in repository? Okay, one query is on this how to find a direct access. I mean, like you want to search a direct access tag from DNA Explorer. So that one option is there actually. This I think many of people may be interested in knowing because like whatever this search bar is provided here, this will give only the loop name search actually. It will not check for the internal tags, what is used, what is the direct access tag, what is used, that it will not be searching. It will be only searching based upon your loop name. So suppose I am having a direct access tag name. So and in which loop it is there, that I don't know. So how to find that also we will see now. So here if you see one search objects button is there. So this you have to click actually. And this object type is there. In this you have to select this direct access port. And this storage and then this hierarchy, this also you have to select. So now it is searching in this repository and whatever this hierarchy is there, suppose like here this BP53 PA header pressure, it will search only in this specific hierarchy. Suppose you want to search for the entire Nalco, then you have to select Nalco 8 so that all packages of Nalco search for this direct access port. So now you know the tag name of the direct access port. So you can select this identifier equal to, and here you can select value. Suppose just a moment. I will choose one tag here so that we will search that same tag and then find it here. Okay, so now this one tag is there, that is let us see in, okay, let us see this one itself. Okay, I will select this tag CDC220 AVL. This is there in Kottagudam. So I have to choose Kottagudam folder, or if you know which folder, you can always select the root folder so that it will search in all your folders irrespective of your folder name. So as of now, for simplicity, I will directly select this Kottagudam AP04 and CJF07 door open. CJF07 underscore door. If even if you are not knowing the full name also, whatever partial name you can you are knowing, you can give star and you can give the search. CJF, okay, is not underscore. Okay, so now whatever you are seeing, that whatever results are there, it will populate all your results. So whatever appropriate tag you are searching for, that will also be coming here. So you can just simply double click on the tag and it will open the corresponding loop where this direct access block is there. So this is a effective method for finding your direct access ports with tag name. Now you can see that your direct access port is here. So this utility is for searching via direct access port or auto info function. So whatever is there, you can use this one. Interface port also you can search. So corresponding object type you have to choose here. Repository you have to choose here. That is storage you have to choose here. And then your hierarchy also you have to choose. Under which hierarchy it has to search. And then this whatever tag name you know, that you can enter here. Okay, so now we have just put all your basic information on this ports and all. So now we will see like how to add certain blocks and how to wire them inside your loop. So I will delete this constant. Sir, yes. I'll take 2 photographs. Okay. you are connecting the wires. How to make a junction? So here wires, when you are connecting, a junction is made if if there is a dot in that. A dot signifies that there is a junction in the wiring. So I will add one more OR gate. So now I will give this as 2, and I want to connect the same inputs to this OR gate. So for this I have to make a junction. There are two ways of making this. First, what we will do is we will directly assign the wires. That is scalar autocolor wire I will choose. And from this input, I am just bringing it down. Okay, now wire I have connected from this first input to this first input of OR gate. But still, the system doesn't consider this point as a junction. So to make it a junction, what I have to do is like I have to insert a dot. So that how we will do it is like this draw. If you go, there is one option called insert dot. So you have to select this insert dot, and then you have to click in this junction. So once in you have clicked in this junction, this dot will be formed, and down you can see these 3 lines are connected. So whatever 3 lines are there, that is now connected to this dot. If you are not making this dot, then system will once again throw an error like this line is connected in the, that is, it is not properly connected. And suppose you want this dot to appear automatically whenever you are connecting the line, then what you have to do is in draw there is one more option, that is dot on off. So now it is off actually. So I am making it on. So now dot on is on. So suppose now once again I am choosing that scalar wire and I am trying to connect this second input. So second input I am coming here. Ha. About the wirings, whatever we are doing for this one. Now there is one more. I will show you what all other options are there in this loop diagrams. Basically, for a single page, you can have like 3 options. That is called sizes, we say. So now, if you want to program more blocks in a single page, then this is like a smaller size. So you will not be able to do it. So you have to add multiple pages. So what you can do is you can either increase the page size or you can add multiple pages. Both the options are there. So first we will see like how to change the page size. Uh, just a moment, I think it is okay. Let's come. Okay. So now if you go to this edit and then you can go to this page and then you can give this create. So now it will like it is asking you two questions basically. How many new pages? That is, if you want to add pages, you can enter here like how many pages you want. Suppose like 1, 2, 3, whatever pages you are entering, that many extra pages will automatically get populated. But suppose if you want to change the page size, then you have to give 0. So now I am giving 0. So now it is giving these three options: normal pages, 2 pages, and then 3 pages. So by default, it will be normal pages. So suppose if you want to enlarge it, say 3 or big pages, then you have to give the corresponding number. I will give 3 big pages. So now automatically your single page, whatever was there, that has increased. So whatever you have configured on the left side, it has automatically come inside. And whatever you have configured on the right side, that has also come inside your loop. Uh, Explain different colors of lines we are using in logic other than analog and binary. There is a query for this colors of lines. Colors of lines we can see here actually. If you go to this draw and then scalar wire, here based upon this color itself, what is the data type that is used, that is provided. So for analog it is green, and then for binary it is black, for integer it is blue. Suppose any fail input is there, that is red. Any float input is there, that is yellow. So these are the different colors of wires that are available. So this you can refer this in draw in scalar wires. Here you can see and correlate like what color is for what data type. Okay, now we have seen like how to increase the page size. So now what we will see is like we will try to add the pages. I will go to page, create, then I will give like 2 additional pages and then I will give enter. So now it will say like after page. This will be useful when you are already having some multiple pages and you want to insert in between. So then you have to choose the page after which you want to insert the additional pages. So as of now only one page is there, so I am entering one. So now the additional 2 pages have come. So here one more thing is there. This page size, whatever we have done, that can be done only when only one page is there in your loop. So that option will not come when multiple pages are there in your loop. Suppose now 3 pages are there. If I want to change the page size, I will go to this page, create, and I am giving this 0. Okay, this new version it is allowing. Okay. Okay, page size also you can change. whenever you want. But only thing you have to remember is like when you are coming or decreasing your page size, your blocks may go out of your page. Suppose like a page create and changing it to big page, and suppose I am adding a here in big page, and then once again I am going to this page create 0, and then I am making it normal. Now if you see, this block has come out. So whenever you are compiling, it will your system will throw an error saying like this block is not part of any page. So this is one thing you have to keep in mind when you are changing the page size when you are having multiple pages. So it is better to what to say, fix the page size initially itself, so that there will not be any change in page size later. Okay. So now let us see one more thing. The usage of this references. There is a reference block which is there. Add reference. If you go to this draw, you will get an option called add reference. Suppose I will take this reference. So here this reference identifier you can give any characters actually. So by default I have given A. So the use of this reference is like you would have seen in this flow charts. First page I will give A with the reference, and then next page if I use A, then it is like that A is coming from the first page. So basically in the case of this multiple pages loops, suppose if I want to use this and get output in the second page, then I cannot draw a line from this page to second page. So in those cases what I have to do is like I have to add a reference here A. Suppose here A is there. I will connect this and get output to this A, and then in the second page I will use this reference same A again, and then whatever logic is to be built I will build with that. So that is the advantage of this using these references if you want to use a particular logic in multiple places. And one more thing, whenever you are creating this reference, there is also an option called draw and then show references, because you may be troubleshooting some logic and you are seeing this reference and you want to know like where all these references is used, in which all pages it is used or which all logics it is used. So in that time you can click this draw, show references, and then click on this reference. So now we have not made any output for this, so it is not showing us any. Suppose I will make one more. Now it is automatically coming here. So now if I show for like draw and then show references and then click on this A, it will show like it is referred here. Same thing I can do for this also. If I click here, draw, show references, then if I click show reference, now it is showing this one. So this show references is basically for cross referencing the reference. So that particular reference you have made, where all it is used in your loop, that you can find with this tool, show references. And now coming to the next thing of like multiple page. Suppose like I have finished my logic in the first page and I want to go to the second page and then I want to start my new logic. So for that you have to go to this page. I think it is in view. You have to go. There are three options, that is next page, previous page or select page. Next page if you give, it will go from 1 to 2. That is the numerically next page it will travel. So we were in page 1. Now it has come to page 2. So suppose if I give previous page, then from 2 it will come to 1. Suppose from 1 I directly want to go to page 3. Then I can go to this view, select page. So now here it will ask me like what is the page number you want to go. So here I can enter directly 3. So now I directly come to page number 3. So these three tools, previous page, select page, next page, this is for navigation between pages. And one thing what we have to remember is like whenever you are creating a logic, suppose now system is thinking like we are in page 3 because page 3 is what is selected. Suppose you just directly zoom out and then do some logic here. You add some blocks here. Then those blocks will automatically get assigned in page 3. So when you are compiling, system will throw an error like you have assigned blocks for page 3, but you have put it in the uh, page 1 whatever borders or whatever is there. So it will show a layer error. That is whatever block which is existing in this page 1, but you have configured it when page 3 was selected. So you should remember whenever you are adding or changing any logic in a particular page, you have to come and select that particular page. Suppose I want to correct or change any logic in page 3. First I have to select page 3 and then only I have to edit or add the logic. So this is one important thing which you have to note down. Okay, I think function wise, uh, these are the major things in FBCAD. If any doubts is there, you can ask, or otherwise we will continue for this. What all blocks are there, and what are the individual block functionalities that we can continue. So before continuing further, if any doubts is there, you can ask, sir. Okay, can the reference created in a particular page be used in other pages of the same loop and other loop? A reference created in a particular page can be used in other pages of the same loop, but not in other loop. It is like the reference is basically like a local variable, so it will be available only to the pages of the same loop. So for example, what I'm saying is like in the speed control, I'm having this reference A. So whatever value is coming in this reference A, that will be passed to only the references A in this same loop. Suppose I am having one more loop, say load control. There also I can configure reference A, but that will pass a different value which is specific to this load control loop. So these references are like local variables and they are only for the loop in which they are created, not for other loops. Second is explain binary and binary event signal difference with example by simulation. Okay. Simulation, only thing is we have to see whether it is downloading. Let me check. think some load issue there. Okay, one more doubt is that can we have different execution interval for a block and for the page? How will execution occur in that case? Actually, as I told you before, you cannot have execution intervals specific for different pages. That execution interval, suppose execution interval, what you are entering here is for the total loop. So you cannot force the system to say like page 1 out of this, see, suppose like 1000 milliseconds is there here and we are having 3 pages. We cannot force the system and say like first page we should execute in 100 millisecond and this second page in say like 400 millisecond and then third page in 500 like that you cannot do. So system will automatically configure the execution times of each and every blocks, but what it will ensure is like all the blocks that are present in this 3 pages will execute within 1000 milliseconds. That is the theory behind this execution interval for a particular loop. And execution interval for a block, there is no execution interval for a block actually. So you can only define the order in which a block has to execute, and your execution interval is specified by this loop, that is loop execution interval. Based upon that, your system will automatically assign a block execution time. You cannot individually define block execution times, that is defined by the system. You can only give a loop execution time. And next query is how can we give multiple inputs to locals left? Yes sir, I think I have already shown that. I will just show you once again. So suppose this is the local port whatever added. So whenever you are adding a local port, there is also one more this thing called dimension of data. So if I want to add multiple inputs, so how many inputs you are adding, that number you have to give here first, and then all those suppose I have given here 5 values. So all that 5 inputs you have to give with comma in between. That is 2, 4, 6, 8, 10. Like that 5 values I have given. So this local whatever port is there, local port, this will be useful mainly for this function generator, where that block requires like a multiple data in a single time. It is not like, it will not take individual say like x1, x2, x3 like that, it will not take. So it will take a group of data. So basically for that block we use this local port. Nowhere else it will be used actually. Only for this function generator it is used. And we have, okay, next query is we have to keep a single @ in the locals or @ for every input for real-time changing. Now @ you can give at the end only. So if you give @ at the end, that is sufficient. You can change any values what is there in the local. A short with short program example. Yes sir, we will definitely do that. Once this is over, then we can see the blocks, and one short program we will do. That is one binary logic as well as one analog logic we will see. Any further query, sir? We will see if it is downloaded. Don't think downloading is taking place. Okay, I think this server download some problem is there. Okay, coming back to that binary and binary event, that's all, sir. Actually, only difference in this binary event data type is like it will show you the time. Suppose it will first show the current status of the binary value, that is 0 or 1. And then next what it will show is it will show the time. Suppose like 0 and then today's date and 4:12 p.m. 4:12 p.m. like that it will show. So that means like it has changed to 0 at 4:12 p.m. Suppose it is like 1 and then 4:12 p.m. is there. That means like it has changed to 1 at 4:12 p.m. So that is the meaning of the time stamping. And what is binary fail? No, there is nothing like binary fail. Uh, no, binary fail like that. What do you mean, sir, actually? You are saying about this fault codes. If it is fault codes, what you are seeing, what you are asking, then okay, I will come to that actually. And simulation, I will try to do, sir. Simulation, I will try to do. If it is working in some other server, I will just check once. Just a minute, sir. I am just looking for another server where I can download actually. Uh, okay. Next is, can we use at the rate anywhere where we want to change the data online? Yes, sir. We can. You can use at the rate anywhere, but it will be useful only for changing any constants. Actually, it cannot be used for any external input ports. Okay, that other server I'm just checking it. So meanwhile we will see like how to make a simple logic here, so that once it is over then we can go for that simulation. Can you please explain briefly the functionalities available under common function blocks 1, 2 and 3 and other tabs in the FPCAT? Sometimes we don't know. Okay. Yeah, that's what we are going to continue as of now, sir. So now I'll tell you like what all function blocks are available and what are the functions or what are the facilities, what kind of logics you can configure with these function blocks. So first we will go with this function blocks 1. So here this AM and AM2 are there. Basically this AM and AM2, these are same only. Only thing is it is AM2 is basically like a advanced version of AM with some extra inputs. So AM2 if you take the bigger one I will take actually. So this AM block you can directly give a tag name so that you can use it anywhere outside or in the picture also you can directly use it. So for this a direct access port name is given for this AM block. So this is basically an advantage. You need not have to configure a separate direct access port for this. So suppose I am keeping this as like one speed underscore CTRL underscore OP. So this I am making. So what all functionalities here that is available is like first is this AV input is there. That is for giving your input value. And then you can also configure this limit values. High, low, low. All these 4 limit values you can give. This you can give using this constants and then float. With this you can directly connect here and you can configure whatever limit values you want to make. And there is also an option for defining hysteresis for these limit values. That is this HHTD, HTD, LTD, and then this one. This if you want any time delay that you can give in this HHTD. That is before creating a high alarm. You want any time delay for creating an alarm that you can configure here. And there is a common hysteresis block that you can get when you are going for these values. This hysteresis one function is there. Here you can configure like what hysteresis you want to make for this greater than and lesser than selections actually. So that you can enter here. So this block is basically like a analog buffer with this high low limits and hysteresis function is inbuilt in this block. And there is also an option for creating fault. So whenever your input goes for any or input has any fault bits, this fault output will become 1. So now if I want to use the any of this block input or output in some other logic, how I have to use I will tell you. Suppose I want to use this out attribute. So then I have to enter like this. 1 speed underscore CTRL underscore OP. This is the direct access name of the block. And then in that I want to use this out attribute. So I have to give colon OUT. So this is how you have to cross reference any of the values in this block. Suppose I want to use this AV. Then I have to give AV here. And suppose if I want to use this HHA, that is high alarm has reached, then I have to give HHA. So this is the way in which you reference this AM block. Our next main blocks here will be like this MCA, MGV, and then MTR. These are mainly used for your drives basically. MCA is basically for your BD, and then MGB is for solenoid valves, and then MTR is for your LTUD or HTUD drives. So here, basically these blocks you will not be creating because we already have specific templates for that. So you have to reuse or copy paste from the template for better configuration of the logic. But I'll just tell you a small simple overview of this one. So this S open, S close, this will be like your feedbacks, limit switch feedbacks, and then your T open, T close will be your torque switch feedbacks. And there is one MA attribute that is for auto or manual. And then this M open, M close, M stop, this will directly come from the HMA function. And if you are having any auto open, auto close, auto stops, that will come from logic in auto mode. And this force open, force close, force stop, these are for this any protection conditions are there, those will be connected here. And apart from this, any emergency stop conditions are there, like say your MCC is disturbed or your system is in overload, or any other extra switch gear not available. So those kind of things we will connect it to this E1 to E6. That is extra emergency protections, which will make your drive to go to fail safe condition. So those will come in this E1 to E6. And then your command will come from this open and close here. So this is for giving command to the drive. So all these three blocks mostly are of the same attributes. So you can once see and correlate them. And then next is your, if you see PID is there. PID also, if you see, this ME is for giving the actual value. And then this all other MFF, KP, TI, TD, TDF, these are all tuning values basically. And then there is an option to give three set points, set point 1, 2, 3. And then all this MA is for like whether it is an auto or manual. And then you can also give a FC in. This FC in will act when FC is true. That is basically in some of your control loops you may need some tracking. So for tracking, what we use is we will enable this FC, and then whatever value to track will be given in this FC in. So with this FC and FC in, we achieve tracking in this PID block. And then there are also some limiter alarms, that is for this actual value, high, low, low, all these alarms you can configure in this ME, HH, HL and LL. And your main PID output is this CON. And then whatever your PID output will be giving to a analog output card. So that card's feedback will be connecting into this CONB. So basically this is for this one only. What is ION? ION is nothing but this is like a PID controller. So both the proportional integration and derivative actions, everything is there. So ION usually will be 1, so that your integrated action is already inbuilt. So it is for enabling integrating action, ION is there actually. Then F mask. F mask, okay. If I give 50° to AV, then what is out signal value? Now by default, your AM block will follow your AV, output will follow your AV. So directly if you give 50, you will get output as 50. And then F mask is nothing but whatever signals are there. There are basically some fault inputs that is defined in your system. But if I use a AM for any fault input, this FA will become high normally. But you do not want it to get high for a certain F masks. Suppose like the fault bit for simulation is like 128. So whenever you are simulating, you do not want the system to think like it is a fault, because you are simulating to override some process parameter. So if that simulation is considered as fault, then your logic may fail. So in those conditions, we use this F mask, and the fault bit, whatever is for the simulation, that value is 128. So we will give this 128 in this F mask, so that whenever we are simulating a certain value, even though in this AV, this fault bit of 128 will come, this FA alarm will not get generated, and this output also will not get that fault bit. So basically your fault bit will not travel throughout your logic, it will get stopped there only. So that is the functionality of F mask. Basically we are masking the fault bit. Then next query is MCA is for bidirectional drives. Yes. What is purpose of A pose and ID pose? A pose and ID pose is like if you want your bidirectional drive to work based upon a PID. That is directly you can give an analog value for open and close. At what position you want to open? So that usually we don't use that much actually. A pose and ID pose. We are using this direct with open close functionality only. So usually there is no MCA block which is controlled from a PID. So when your bidirectional drive is also having a PID, then this A pose and ID pose will come into picture. What is parch? Parch is nothing but parameter change. So whenever you are changing any tuning parameter online, so that time your PID will not directly take that changed parameter unless and until you make a small change in this parch. This parch is nothing but like a confirmation for your PID that you have to use the change parameters now. So unless and until you enable this parch parameter, whatever values you have changed, tuning values, KP, TI, TD, that our logic will not consider. How to find each attribute description? For example, take a PID block. Okay, this help manuals you can directly get it. That is like edit values, and then whatever block you have created, that block you can click. So there is one option that comes here, that is type help. So this type help you can click here actually. So now a manual will actually open in Internet Explorer for this PID block. So here you will see all the parameters. Suppose PU, what is the data type of each parameter, what is the initial value of each parameter, and what is the functionality of each and every parameter, what is its use in that particular block. All those details will be given in this help manual. So this is how you can see like what attribute and how it is used, that you can verify here. How to add specifier to convert timestamp signal. If we change the hysteresis value in AM2, what will happen? Okay, first I will finish this hysteresis value. Suppose this hysteresis value now here it is given as 1, and suppose now I have given a low value of 0. So my LA output will become 1 whenever my input becomes less than 0. But it will not reset unless and until my input goes above 1. That is because your hysteresis is 1. So suppose if I change it to 2, then once it goes below 0, LA will become true. But it will not become false unless and until your input is greater than 2. So that is what hysteresis is for. So whenever it is resetting based upon this hysteresis value. And then how to add a specifier to convert timestamp signal. So for this, we have this draw and then insert specifier. This is there. That is, if you want the specifier to be on the left side or right side, you can choose both the options. And there are multiple specifiers which is there. So if we use a timestamp signal, that is binary event, your binary value is at the bin. So this actually this specifier things you can see in this DNA manuals. I will show you where to see that, so that you can know like what specifier code you have to use for converting this values. So if you open this DNA manuals, there is something called type collection. So suppose now I want to use for this binary event. So I am clicking B. So this is the binary event bin new. So now you have to use this colon bin stat to get the binary value, because binary event consists of these two things. One is bin stat, which gives the value, and one is b in time, which gives the time. So suppose if you want to extract time, then in the specifier you have to give like bin time. Suppose if you want to extract value, then you have to give this bin stat. So that is how you get the thing from specifier. So the same thing you can see for all this analog and everything here actually. So whatever data type is there, you can come to this type collection. Here you will find like what all components are there inside that particular data block. So based upon that you can see like what has to be selected for specifier. Thus motor drives or any other drive will operate automatically when ACN is restarted. No, generally we give the failsafe state as like, or the initial value what we are seeing for that particular block, it will try to be in off state only, or usually it will be in like a no change state, so that there is no change in the functionality when you are downloading. If it is on, it will remain on, and if it is off, it will remain off. So that is how we program the function block, so that there is no change when you are downloading some motor drives. Can we control PID's con using COLMI and COLMA? Yes, these are actually like limiter values. So you can limit your con output within this call MI and call MA. So suppose if you want say like 0 to 100, you want to limit it to 0 to 50, then you can use this COLMI and COLMA. Can we tune PID control block of particular wall virtually, and after getting satisfied virtually we can download to real? Virtually in the sense you can do it in actually in sites we don't have any virtual simulation actually. So virtually simulating, I don't think that is possible, but there is also a utility which we call PID auto tuner. So that will depend upon like what kind of software you opted in your contract. So if that PID auto tuner is there, then you can see actually, that is like it will try to auto tune your PID and it will show the control diagram and then once you are satisfied, you can test it actually. So that is one way of checking this PID without downloading to real. But it depends upon the option of contract. Can motor drive generate off command second time if failed to stop at first attempt? Can motor drive generate off command second time? Usually, whatever commands are there, they are like pulse times. So it will only operate for a maximum of say like 10-15 seconds or whatever is configured in the block actually. So after that time, it will die and it will give an error like it is failed to stop or failed to start, whatever may be the condition. So then, if you have to give it second time, that is like then you have to acknowledge it and then you have to like correct it in the field side. Basically, like why it has failed to stop, that you have to attend first in the field side, so that you we call it as like a watchdog whenever this kind of alarm comes. So once that is rectified, then that watchdog will get acknowledged, and then if you give another off command, then it will take actually. How to add a bin stat and bin time to a tag? No, it cannot be added to a tag actually. Basically, when you are connecting the wires, when you are connecting the wires, suppose you assume that this is a binary event, you have to give the specifier, and at the connection point, you have to click, and then you have to give the specifier like this. Suppose like bin stat. So like this you have to enter. So you have to enter at the destination point to take from this one. Now the motor. Oh, we did not got that the second time even after we attempted. So that's what actually as I am saying. You cannot get it unless and until that watchdog is acknowledged. So if you want to give one more off command, first you have to get that watchdog acknowledged actually. So for getting that watchdog acknowledged, whatever is the field side that has caused the watchdog, that has to be corrected first. Then once that watchdog is acknowledged, then you will be able to give a second time command. Even though initial values are correct, the motor started at the time ACN restart. That once again you have to see like because of what it has restarted. Because if any auto condition has come or any protection condition has come for short, whether it has started because of process or whether it is like from block it has restarted. So that once we have to check. Watchdog. Watchdog conditions. Just a minute, sir. Suppose like this MTR. MTR2 block. Suppose like for motor, I will show you what all watchdog functionalities are there. These are the watchdogs that is available for a motor drive. That is basically this WDD in that motor block will indicate what is the value of watchdog that is there. 0 means no fault, 1 means fault starting, 2 is time to on, that is on has taken more time than required, and then fault stopping. This is like without any block command, the motor has stopped by itself. And then time to off, that is off time has exceeded the pre-configured limit. And then status in faulty, that means one of your feedback is in fault. and then on and off back faulty. That is like your command. Whatever we are giving commands. So whether if any one of your DO commands, the particular module what you are using that is having some fault actually. So in that you will get this on back and off back faults. Okay. So this is the different watchdogs that is available. How to add reference in a page when I can refer from another file without creating tag. No, actually you cannot add reference between two different loops actually. Reference can be added only within the loop. So if you are taking some signal from another loop, then you have to create either this external incontinuous or direct access port to access the tag actually. You mainly have to create an external incontinuous port only if you want to take tag from another loop. We got WDD4. WDD4 is like time to off actually. That is your off time off has occurred, but it has taken more time. How to acknowledge in your pop-up itself, I think you will get one option. I don't know whether here it comes. Actually, in your loop window, actually, if you see, once you open loop window, and then if you expand it, at the bottom, you will see something called like a watchdog. And there will also be a tick-like button, which you can use for getting this acknowledgement actually. Not able to open here. I have seen in our logic with reference HPCV1, which is referred in another loop without any tag. Now I think you are saying about this interface port. It is not reference actually. It is interface port might have been used with instead of here I have used colon out one. They might have used colon HPCV1. So in that case, how you have to use it in the other tag is like this. Here I have shown right. One you have to enter the loop name where this colon HPCV1 is there. So here my out one is in this PR under PR colon one speed control dot F. So whatever is your loop name in which colon HPCV1 is there, that you have to enter first, followed by your interface output port name. That is in my case it is colon out one. In your case it will be like colon HPC1. So that is how you can interface port if you want to use in other logic, you can use. So if you are using interface port, then there will not be any tag name like direct access port, and you have to reference the interface port like this. Okay, so then this F block 2, there is this CCY is there. Basically this block acts like a buffer. So whatever is your input will come in your output based upon the mode. So this block we use for any testing, any troubleshooting. We change the mode as 1 so that we can directly change the output without without taking the input value. You can directly give any output value. So for that also we use this CCO blocks. Next, if you see, there is called dissex. This block is for like a selection of inputs based upon this BSC value, whether input 1 or input 2 will be selected to output. So BSC is 0, input 1 will be in output, and BSC is 1, input 2 will be in output. So this is basically like a selector block. And other this NOT gate is a simple NOT gate actually. You can for input and then for NOT inverse you can use it. Then main function block, this pulse is there. This pulse block can be used for pulse as well as for delay. If you want to use for delay, then here you have to write like delay. And this up or down is for this delay up or delay down. So if you want a T off, then you have to give down here, and this SSTA you have to make it as 1 in that case. For T on block, up will be there and then 0 will be there. So only for T off, this will be down and this SSTA will be 1. For all other cases, it will be up and then this will be 0. So once you have added this block, then you should also connect the pulse time. You can give it in constant also. Whatever is the pulse time you have to give here. And in control you have to give the input. So this is pulse function block. These are the major things, and then one RAM block is there actually. RAM block mainly may be used for your set points. Whenever we are creating any delayed set points, so that time we use these RAM blocks. So suppose this RAM power block is there. So here whatever value set point that is to be ramped, that will give in SP. And then this up rate and down rate, that is our rate value, you have to give in U rate and D rate. And then if any tracking of set point is there, that you have to use in this FC in. And this ramped output will be available in this ramp. And then run indicates like there is some ramping function going on, and up or down indicates like what direction the ramp is going on. Then in loop window some faults are mentioned. What's the significance of individual fault such as external fault, inaccurate signal, etc. Okay, external fault is basically like a wire break fault, and then inaccurate signal is for like in temperature transmitters, not temperature transmitters, suppose like in RTDs. If any wiring reversal is there, that time it will say like inaccurate signal. And there is also a fault for old data and external, that is like derived fault is there. Old data means that whatever data is there, it has got frozen. So and now old data is used, that is. And this derived fault is like, suppose you are having a function, that is, suppose like you are having an AND gate, your input is in external fault because of some wire break or something. Okay, suppose you are having some calculation, so one of your analog inputs is in fault, so that input will be in external fault. And suppose you are having a calculation like input 1 plus input 2, so now your output will see like one of your input is in external fault, so your output will go to derived fault. So it is a derivation of your derivation. Whenever a calculation is happening on a fault, that will happen like a derived fault. And next is this simulation. Simulation will be like whenever you are trying to simulate a signal, that time it will show like 128, that is simulation fault. And then significance of E1 to E5 error signals. E1 to E5 is not error signals. E1 to E6 are there, that is there in this MTR and all these drive blocks that is there. Those are basically for any emergency fail-safe condition if you want to if you want your drive to go. So those conditions you can configure in this E1 to E5. How to add that out1 colon 1 in a particular page? Significance of SSTA. Significance of SSTA is basically it is like a starting state, SSTA. So if you are in up direction, your SSTA will be 0. And then if you are in down direction, your SSTA will be 1. So only you are going to give down when you are trying to use this pulse block as a T off. So only during that time you have to make this SSTA as 1. Otherwise it should be 0. Because all other cases this UDS we are making it as up only. So that is the significance. How to add that out one in a particular page? That's all, sir. You can go for this common interface out, and then you can select the data type, and then you can add it. Directly output will come. So till F block 2 we have seen, and then in F block 3 these major function blocks are calculator. Calculator, the thing is you have to enter formula. Suppose like this is a 2 input calculator, so I can enter O equal to A plus B, and then once the formula ends, you have to give this semicolon. Then only system will think like formula has ended. This formula you can enter in multiple lines also. Suppose I can write like O equal to A plus B, and then here I can enter the semicolon. Then also system will take like A plus B. That is why these multiple formula lines are given, so that you can continue the formula in the next line also. And then because each formula line is having a limitation of 16 characters, more than that you cannot enter in one formula line. So if you have a very bigger formula, then you can continue in the next line, and after the formula is finished, then you can give the semicolon. So this is how you work on the calculator block. Then next is this comparator. Comparator is also a similar thing, but it will not do any calculation. Here you can only make this greater than and less than comparisons only you can do here. So this formula will come like this. And this and or and all we have already discussed. So these are the major blocks which are used actually. So any other block you want to see, sir? For pulse up, if I put SSTA is 1, what happens? No, if pulse up, if you are putting SSTA as 1, it will not function as a pulse up actually. It will be like initially for 0 it will be in 1, and then whenever your output is changing, then it will become 0. So basically it will not work as a pulse up. That is T pulse, it will not work as that. Explain about INT block used in turbine logic. Okay, integrator block is, I think it is a composite function block. What is there? So it is basically like a RAM block only. Only thing is that it is having a in RAM block. If you see, direct rate is given. There the rate is based upon your x and t. That is x by t is your rate. That is in your integrator block. So whatever is coming in x divided by whatever is the time that is configured in the integrator block will be the rate at which your value will be increasing. And what is the increase or decrease is based upon your maximum limits and minimum limits. That is, whenever x is positive, it will go towards maximum limit. That is, ramping will be in the upward direction. And whenever x is negative, That time your ramping will be in the minimum limit, that is in the negative direction. So that is the main functional of this INT block, and it is also having a tracking function which is with this S and I. So whenever S is 1, that time the integrator block will not bother about this X and T. It will directly give the input I to output whenever the S attribute is 1. Okay, sir. Any other query, sir? Oh. And SSTA conditions in a single block. No, as I told, actually up slash down and SSTA, this down functionality will be used for T off delay. That is when you want to use the pulse block as a T off, that time you have to make it as down and SSTA will be in 1. Basically the block can work in multiple directions. That is, a single block can work for different functionalities. So for that only this different varieties are given. It is not like for up you will use SSTA as 1. SSTA 1 is basically option is provided as SSTA 1 when you are using down. Okay. Yes. Yes, sir. Actually, it is like off delay timer and on delay timer. If you use the pulse block with like instead of pulse, if you give delay, then it will function like a on delay and off delay timer. The time you can use this up and down, and then you can see. Can you please send Walmart DNA manual to mails? This Walmart DNA manual will also be available in this PCs itself. So you can directly take from the PC also. If you require it in some CDs, we can be able to provide it. But you can directly take from the PC because that will be more convenient for you also. You can directly go to the start and then search for you can directly go to the start and then search for DNA manuals. So this you will directly get here. So basically this is the path DNA www root eman DNA English. So this is the route where all the manuals are kept actually. So you can directly go to this route. So all your manuals are put in this different folders. So you can directly take from there. PCS function is there. Here you will find all the manuals by name. Whatever blocks are there, for each and every block you will find the manual in this one. Next query is not clear on MOV block error signals. No, MOV block error signals. What you wish is that? Can you be more specific, sir? What MOV block error signals you want? When we use TD and TDF in PID. No, that is for if you want a derivative action, then you have to use this TD and TDF actually. Usually derivative action is not used in many other controls. Maybe in speed control and some other where any feed forward action is required, there only we will be using this TD and TDF. How to use timer, counter blocks, analog value integrator. Analog value integrator, you can use this ramp block, what I have said. So rampar is the easiest block for this integration. So in that you can directly provide the rate of increment or decrement, that U rate and D rate, what I have shown here. So it will be increasing at this specific rate actually. And then for timer, I think you are asking for this T on T off timer. So T on and T off, you can use this pulse block only. And this mode you can configure as delay. So that itself will give you like a time delay function also in this pulse block. For counter, you are having a counter block here. So here you have to mention like the input will come. Suppose what it has to count, that has to come here. And then on minimum and maximum, that is what is the range of the counter till what time it has to count. And then round, mode, all those things are there. So based upon whenever your input changes, suppose from 0 to 1, 0 to 1, that time it will start counting so that you can know like how many times it has changed. This you can use for any counting function actually. Next is can we build custom block using basic blocks? And if so, where this block resides? Yeah, you can make any custom blocks actually. Here we say it as like composite function block. You can go to this object, and then you can go for create, and then you can say like a composite function block. Okay, it is not opening. Just a minute. I think it is not opening here. Usually composite function blocks. Okay. This is not happening in this one. Okay, next. How to check SR flip-flop is set dominant or reset dominant? That you can see in this one. It is this F blocks hand or left. RS is there means then it is reset dominant. SR is there means then it is set dominant. So this is how you have to choose the function block for different functions. Can you explain about incremental override and decremental override and arming functions? Incremental override and decremental override usually may come in your PID controls. Suppose like there may be some protection conditions in which irrespective of your control output, whenever that protection condition has happened, you want to close your wall or you want to open your wall. So that time we use this incremental and decremental override functions. Basically these are not part of the basic function block. So we have made a template which can externally achieve this function. So in your template, if you see, there will be a option for giving this incremental override and decremental override values. So in this basic block, if you see, there is only like whatever you are seeing, it is all with values. If you go to this edit and design members, there will be nothing. But in case if you see our any configured loops, suppose like this AI DI loop I will open. Here you will find multiple design members. So these design members are usually configured for ease of your logic basically. Because now I have already put this UID tag and then here itself I am writing this package and then execution time. All these attributes are directly exposed here. So once you change this design member, all the individual values on multiple places will get changed automatically. So in your template of PID itself, you will find attributes for this incremental override and decremental override functions. And arming function, I think your it will come in this protection sphere. Suppose like main steam protection, there is an arming function. Suppose once your main steam temperature crosses beyond a particular point, then only that protection is armed. So that is activated after that. After that, if your main steam temperature comes down, then it may cause a trip. Otherwise, function will not be like activated. So this arming function is basically for that. Any other queries, sir?
Any more oral questions from participants? You may unmute yourself and ask, please. I think, Shriram, I think they are done with. Shriram?
Hi, sir. Yes, ma'am.
I think they are done with their questions now. If anyone
Okay.
has got anything, even now you may come up, please. Otherwise, thank you, Shriram, for having given us such a nice lecture and in-depth topic of this has been dealt today morning as well as in the afternoon sessions. So I hope our customers are benefited out of this. And so there is one more question.
Yeah, actually, if we change any value in real time,
BU updated
Which we
in BU.
updated in BU.
Huh.
No, sir. Actually, BU does not take any online values. Whatever blogs and functions we are downloading, that is what is getting updated in the BU. Not the real-time values are not getting updated in the BU. So that is directly taken from the ACN and it is displayed in your system. So it will not be like changed in the BU. And what are those IO/module tabs in FBCAD? Actually, FBCAD, if you see in your DI or AI function blocks, you will be seeing some buffers here. MIO, M120, AI8 like that. So this IO and this module belongs. Now we are using this ACN IO M120 series actually for all your Palmer projects. So you have to go to this group and whatever block is there that you have to use analog input or analog output. I think this blocks and addresses, I think morning our Kiran would have explained actually how to give address for a particular buffer and what all functionalities are there in these blocks actually. Suppose if you want to use a redundant block, then you have to use this M120 redundant series. And what block you are using, based upon that you have to use this analog input. In analog input also multiple types of modules are there. So what is your actual module, based upon that you have to choose this buffer. So this IO and modules are for this one. This modules basically it will have other events also, like events, position. Suppose like you want to create an alarm point or you want to create an event point, and suppose you want a loop window for a particular function. So for this position, operation and event, these things are used actually. And if you want a history function, that is you want to store a particular data in history, that time you will be using these history blocks. And then so basically this module blocks are for that. So I hope that clarifies the question. Any new versions of FVCAD available or supplying to new projects? Version of FVCAD, I think it will keep on changing based upon what is the OS there. If it is like a Windows Server 2008 or 2012, it may be of different version. If it is like say now Windows 10, I think 2018 or something has come. So basically the FVCAD version will be dependent upon what is your Windows version. What will happen if we download main loop and child loop for a PID online? You can download a main loop and a child loop of a PID. Only thing is you have to notice that it will reset to its original thing because it is a controller. So suppose your control wall is in say like 50%, and then you are downloading. Basically, what initial value we will be given in the PID is like 0. So your control wall will once close to 0 and then it will come. So it will not be a smooth transfer when you are giving an online download. So whenever you are downloading these loops, you should be careful so that your process is not affected. So usually if you have changed only some values, you can give a download update instead of a download replace, so that only that particular value is changed. And whenever you are giving a download delete or download replace, you better do it in a shutdown condition so that your process is not disturbed. Sir, how to enable simulation for a particular tag? Simulation function you can directly enable in your HMI screen itself, provided it is configured in HMI side for enabling of simulation. So if that is there, you will get a option in this maintenance and then sim iOS main tests. Actually here this is not enabled. Actually if it is enabled, it will open that simulation window where you can try to simulate that particular tag. How to add extra interlocks in child loop logic base if all are used? Extra interlocks in child loop logic base if all are used. Okay, you mean to say your function is having, your particular drive is having more interlocks than what is available in a standard loop. So for that, actually, you may have to combine two interlocks, and then in when you are writing the text, you can write the text of both interlocks. Or otherwise, we may have to design a new child loop for multiple, that is extra interlocks. So these are the two options. With existing thing, if you want to use, then you have to combine two interlocks. Next is how to enable maintenance window for simulation. This actually our HMI will be able to help you whenever our HMI session is there. You can ask this. Actually, they are having some data files, so in which they can run that simulation software. So when they enable it in their side, actually you will be getting that option to simulate directly from your HMI screen. Any further questions, sir?
FB sim.
FB sim. No, FB sim. What do you mean by FB sim, sir? FB sim significance. Can you clarify further on this? What do you mean by FB sim?
Sairam sir, you may you unmute yourself and speak also. Sairam sir, shall I unmute you?
Hello, sir.
Yeah. Tell me, sir.
Sir, actually, I have seen in the main page. I mean, if I take any drive in that main page, I have seen small picture FB sim. If I take any main drive's main page instead of child loop,
Okay.
in main loop,
Okay.
I have seen
Okay.
FB
Okay.
sim. Yeah,
Okay.
yeah, that
Okay.
one.
Yeah. I got it actually. That is, I think. Here they are not configured in this server. Okay, that is the block which is enabling simulation from HMI, sir. If that
Oh,
sim
yeah, that.
block is not present in your
Okay.
logic, you cannot simulate directly from HMI. You have to simulate using our CCOA blocks only.
Then how
If
to
that
add that FB sim block, sir? How to add that FB sim block if it is not there?
usually it will be in the design member itself, whether simulation has to be enabled or not. Like, see, simulation is there, measurement is simulated or not, 0 and 1. So you can make it 1.
Okay. Fine. Okay.
So once you make it 1, that FB sim will automatically appear in your logic. So then you have to give a download.
Oh, then later download. Okay, sir.
Yeah. Then actually that option for simulation also be to be enabled in HMI side. Then you will be able to simulate from HMI.
Okay, fine.
That is how the entire simulation philosophy works, sir.
Fine, sir. Okay.
Okay, sir.
Okay.
Next
Thank
is,
you.
can we increase the number of interlocks in design members of child loop? So that is what, sir. Actually, if you want to increase the interlocks, not only design members you have to increase, but whatever blocks we have added for this interlocks, that also you have to configure, and whatever display functions we have made for this interlocks, that also we have to configure. So it is like we have to create a new child loop and new interlock provision for this drive. Or with existing thing, if you want to use, the only probability is like you have to merge two interlocks by using AND or OR gates, whatever is your requirement. And text also you can merge. Suppose like if you want to use like pressure is less than this, and then drive is on. So both you can make an external AND gate and then connect it to your child loop. Ask FB blocks significance. Ask FB is for basically for segregating your fault bits from your analog value. So suppose I will add Actually, that's what actually. C drive is full actually, but I cannot delete anything here because it is a common laptop what we are using. So okay, I will just tell you the functionality. As feedback, as I told you, it is for extracting the fault bit from a analog function block, and suppose it will also be used in signal selector functions. Suppose you are using say like a 2 out of 3 transmitter selection or 3 transmitter selection. So in those cases, there may be particular instances in which you want to force the output value to a fault condition. So for that, this ask FP can be used actually. So if you want to extract fault from analog block, then also you can use ask FB. Or if you want to add fault to some analog value, then also you can use this ask FB. So that is the two instances in which this ask FB blocks are used. Any other questions, sir? Any other questions, sir, or we can close actually?
I think we have had a in detail session of this FBCAT today. So this will definitely help them. Thank you, Sriram, for having taken so much trouble and explaining in depth. Thank you very much, participants. Stay safe. Tomorrow we'll meet at the same time at 9:30 sharp. We will meet so that let us not delay it. Today we got delayed 10 minutes and other faculties also got delayed. Let us not create that situation tomorrow and let us be on time 9:30 on dot. Thank you all. Stay safe. Good evening. Thank you, Sriram.
Thank you. Thank you all.